Hey guys, I'm back with a new video. In this video, let us learn about how we can add a node to the end of the linked list. Now in the previous video where we learned how we can add a node at the start of the linked list, we discussed about the zero size addition case, when the size of the list at its initial moment is 0, as we know. So here also the same case comes when initially the size of the linked list is 0. So the zero size addition case was that you first create a node, you assign some value to it that the user gave you, so say 3. Then this node will become the head of the linked list because it is the very first node that gets added to the linked list, and currently it is the only node that is present in the linked list. Now since it is the only node that is there in the linked list, we can also interpret this as the last node of the linked list as well. So tail will also point to this node. And we'll increment the size of the linked list by 1 because now we are having one node in our linked list. So now the size of our linked list is now 1. Now let us see how we can add a node at the end of the linked list. So say user gave us a value of 5 that we now want to add to the linked list. 3 is done. So the very first step is to create a new node. So this is how we create a new node. We assign a value of 5 to it, and then we assign the next pointer of this node and make it point to 5. So we now want that the next of the tail should point to 5. So here goes our next pointer of this node. So now we have a new member in our list, but we have to update the position of our tail pointer. So now our tail should point to 5 instead of 3 because 5 represents the end of the linked list. So let us remove the tail pointer and now make tail point to this node. And finally we have to increment the size of the linked list by 1. So now size becomes 2. And similarly, if the user now gives us a value of 7, we will again create a new node. We will assign the value of 7 to it. Then we will assign the next of the current tail to this node that we just created, like this. And then we will upgrade the position of the tail pointer to point to 7. So tail will now point to 7. So this is the entire logic of adding a node at the end of linked list. So let us implement this. So let us switch back to Visual Studio Code and try this out. So adding a node at the end of the linked list, which is problem 2, say. Now let us implement the method for adding the node at the end of linked list. So void add at last. This will take on some value. So as I already told you, for this we will make use of the tail pointer that we defined earlier in our code right here. Though you can also add a node by traversing the entire list in a for loop and then appending the new node at the end. But for now let us keep it simple and make use of the tail pointer that we defined right above. Now as a very first thing, let us check whether the size of the list is 0. If it is 0, then we have to add a node to the list, and in this case whatever node gets added to the list will itself be the head as well as the tail for the linked list, as I just explained. So for this we already have a function that we defined just a while back, which is handle zero size addition. So let us call that and pass the value that we got as the argument to this function. So if the size of the linked list is 0, let us return handle zero size addition to create our very first node of the linked list by passing this value. So this node will become the first one to enter the list and will be both the head as well as the tail of the linked list, as I just discussed. Now once the zero size case is handled, then comes the non-zero size case, where we simply have to add a node at the end of the list. So now comes the other case, that if the size of our list is not 0. In this case, to add a new node at the end of the list, let us follow first the usual steps of creating a node and adding data to our created node, and then we will see how the tail pointer comes into picture. So to create a node, let us say node, new node, and then let us add the value that we got as argument to the data of the node that we just created. Now we already have tail pointer pointing to the last node of the list. But what we want is that the new node that we just created should get placed at the end of the list and should become the new tail of the list. So doing this is very easy. Let us do this. So on whatever node the tail pointer is sitting at, let us set the next of that node to the new node that we just created. So this dot tail, so whatever tail we are currently having, set its next pointer to point to the node that we just created. So now we have a connection from the tail of our linked list to this new node. Finally, we need to do two more things. One is to make tail pointer point to this new node, because now we have a new node that is sitting at the end of the list. So tail should also get updated, as I discussed in the example. So this dot tail will now point to the node. So now the node that we just added to the list is the tail of the linked list. And next, we need to increment the size of the list by saying size ++, because we are having a new member in our linked list. So this is the entire implementation of the method to add a node at the end of the linked list. So let us go to the main method in order to invoke the add@last method on our linked list. So right here, let us try this out. Linked list.add@last, say 67, and let us call the display function on this to see the current status of our linked list. So let us compile the code and run the file. So java c linked list.java. Okay, so we are getting some error. Let us rectify this first. This should be handle 0 size addition and then just return. So let us again compile the code and run the file. Java linked list. So here we go. Now the very first thing that is happening here is that we first created an instance for our linked list. We add 1 to the start of the list. Then we added 2 to the start of the list. So it becomes 2 1 till this point. Then we added 3 at the start of the list. So now it becomes 3 2 1. Then we added 4, so 4 3 2 1. We made a display call, so we get 4 3 2 1. Then we add 67 at the end of the linked list, which makes it 4 3 2 1 and 67. So this was all I wanted to cover about the case of adding a node at the end of the linked list. So let's catch up in the next one.